G'day guys, we've got a couple of algebra questions today where we've got to solve the following equations by completing the square. Now what completing the square is we make use or exploit what's called a perfect square in quadratic equations to essentially just use simple algebra to then go and solve it. So what a perfect square is in quadratic equations is if we have something like x plus 2 all squared. Now we can generalize this to something like this. We could have x plus a all squared. Now what this is when we expand this, rather than being x squared plus 2 squared, which it's not, it's x plus 2 times x plus 2. And in this one we have x plus a, x plus a. Now, in each of these, if we were to multiply these out, like a lot of people use this FOIL method where you go first, outside, inside, last, where we're going to have x squared plus 4x plus 4, and in this case we're going to have x squared plus 2a, x plus a squared. Now, what we can do here is you can see that the middle term, i.e. this one, or this one, is double that of the term in the perfect square. And we use this little fact to basically to help solve these equations. Now that is basically all the knowledge you're going to need to be able to solve these. So what I'm going to do is, if you keep this in your brain, we're going to use this fact that 4 is double 2 and 2a is double a to solve all of these equations. So let's get to it. Okay, so here we have x squared minus 2x minus 15. So what I'm going to do is, I know that what I have to have in my bracket has to be half of this b term. So what I'm going to do is I'm going to say, well, this is going to be x minus 1, because 1 is half of 2, all squared. Now what I have to do now is, once you've done these a few times, you'll be able to do this without figuring it out like this, but then you're going to go, well, if I multiply this out, what am I going to get? Well, if you multiply this out, you get x squared minus 2x plus 1. Okay, now if you look closely, you can see that this part here of our equation is exactly the same as this part here. So we're basically good to go on that bit. What we only need to do now is we need to get rid of the fact that we have a plus 1 here and replace it with a minus 15. So rather than having plus 1, what I'm going to do is I'm going to go, well, x minus 1 all squared, which will give me this. Then I'm going to subtract 1, and that'll get rid of this. And then I'm going to subtract 15 to put that on the end. And that equals 0. So if I combine my like terms at the end, I get x take 1 all squared minus 16 equals 0. Cool, so basically what we've done here is that's the completing the square part under control. So that's the completing the square part done. Now we just have to use algebra to solve it. So what we do is we take our 16 to the other side and we get x minus 1 all squared equals 16. We then take the square root of both sides. So that means we're going to have x minus 1 on this side. But just to make sure, when we take the square root of this, this is going to be plus or minus the square root of 16, which is equal to plus or minus 4. Cool. So we have x minus 1 equals plus or minus 4. And then we're going to take the 1 over the other side, and we're going to have x is equal to 1, because we plus 1, plus or minus 4. So 1 plus 4, x equals 5, or 1 minus 4, x equals negative 3. So that's how we solve that first one using completing the square. Now each of these increases in complexity as we go on. So let's just separate our questions. Cool. Now, what we're first of all with this one we have to do is we have to take that 6x over to the other side. So we have everything equals 0. So we're going to go, that's going to be 4x squared, take 6x, take 1, equals 0. Now, as you can see, this completing the square sort of way of doing the questions, tool, method, whatever you like to call it, really only works when you have a monotonic quadratic. So we need to get this 4 to be a 1. So what we're going to do is we're going to divide both sides by 4. So the way that works is we're going to factorize the front by 4. X squared, 6 divided by 4, which is equal to 3 divided by 2. X minus 1 divided by 4 is just 1/4. Equals 0. If I divide both sides by 4 now this is what's great about having something that's equal to 0. If I divide both sides by 4, I can essentially just get rid of that 4, and this is still equal to 0. So I still have x squared minus 3 on 2, x minus 1/4 equals 0. Now, like we did before, I'm going to halve my middle term and put it inside a bracket. So I'm going to have x take 3/4 all squared. Now what I'm going to have to do is I'm going to have to negate, like we did here, the 1, which is just our middle term, which is our inside the bracket term squared. So I've got to negate the fact that I've got 3/4 squared. Now 3 squared is 9, 4 squared is 16, and then I'm going to plonk my last term just on the end. And that's equal to 0. So I can combine these like terms. So 9 over 16 minus this will be 4 over 16. So we can turn this into 9 minus 4 is 13. Minus 13 over 16 equals 0. So we're going to then, so now again from here, our completing the square is done. So what we can do here is just from here we're going to use algebra. Now I'll go through this algebra a bit faster than before. I'm going to take the 13 over 16 to the other side, and I'm going to square root at the same time. So I'm going to have x take 3/4 is equal to plus or minus the square root of 13 divided by 4, because the square root of 16 is 4. So what I can then do is then I can take this over to the other side and go, well, x, oh wow, x is equal to 3 plus or minus the square root of 13 all on 4. So you could have, the full answer would be x equals 3 plus 13 on 4 and x equals 3 minus square root of 13 on 4. But I'm just going to leave it there for space reasons, and I think you guys hopefully will just get that. It shouldn't be too difficult to understand. Now, split it up again. Ooh, just got it. There you go. So, finally, this one. Now, I can already see that this one's going to be a bit of a nuisance. Okay, so like we did in the other one, let's make it equal 0. We're going to take the 4 across, and we're going to start with 3x squared take 2x take 6 equals 0. We're going to divide both sides by 3 by first factorising the front by 3. X squared minus 2/3 x minus 6 on 3 is 2 equals 0. Divide both sides by 3. Cool. And what that does is we cancel to get rid of that, and that's still equal to 0. And we have x squared minus 2/3 x minus 2 equals 0. Great. So what we're going to do is we are going to halve the middle number. So half of 2/3 is obviously 1/3. So we have x take 1/3 in brackets. We're going to square that. Then we're going to negate the fact that we're going to end up with this weird term at the end, which is just going to be 1/9, because 1/3 squared is 1/9, minus 2. But I'm going to put that over 9 straight away, so minus 18/9 equals 0. So -1 take 18 is -19. So we have x minus 1/3 all squared take 19 on 9 equals 0. Now, like last time, guys, that is our completing the square under control. So from here, what we're going to do is I'm going to just, algebraically solve it. Like last time, I'm going to just do the first two steps in one. I'm going to have x take 1/3 is equal to plus or minus the square root of 19 over 3. So x is going to equal 1 plus or minus the square root of 19 all divided by 3. Cool. So again, like the other one, 1 plus the square root of 19 over 3 and 1 minus the square root of 19 on 3. So if you were able to get that, that's your final answer right there. So guys, what are my thoughts on these problems? Well, they can be tricky. However, if you understand the method, method never changes. You've just got to make sure you're in this ax plus bx plus c equals 0 form to start with. So you're in this sort of quadratic form like this, ax squared plus bx plus c equals 0. Once you're in that form, you're making sure that a is equal to 1 by first factorizing by that number. You take it over the other side, so it still makes it 0. And then you just do the same old, make the middle number halve it, cancel out the c term that it'll form that you don't want, add on the c term that you have, and then algebraically solve it. So I hope this video helped, guys. If it did, give it a thumbs up. Hit the like button, do my channel a favor, subscribe. I put out new videos almost every day. But until next time, guys, just keep enjoying your maths.